So, hello everyone. Today I'll be covering two questions. First is one is from the trust part. So, you all know that analysis of trust is very lengthy in a way. So, we'll see a method through which we can reduce the time of our analysis. And the another problem is about calculating shear force, bending moment, and axial force in a semi-spherical um, bar, you can say. So, let's start with the trust problem. Please sit with your pen, pencil, and paper so that you can do some part with me. After this problem, we'll do a practice problem too. So let's start now. So this is a question from GATE 2022, set 1, and question number is 50. So the problem is the plane truss shown in the figure is subjected to an external force P. It is given that P is 70 kilonewton, A, the distance of the members, some members is A, length of some members is A, and some members is B. So the value of A is 2 meter and B is 3 meter. We need to find the magnitude of force, the absolute value of force in member EF. Okay, so you can, it's a 2 mark question. I mean, there's no negative marking in it, but when you see the problem, it seems very intimidating, right? It's a very big problem, and to find the force in one member, we need to solve the entire truss. Okay, and in GATE we have just 2-3 minutes to solve a problem. Okay, so how to reduce the problem in such a way that we can cover it in lesser time? Okay, so there's a concept of zero force member. How many of you are aware of that zero force member? Just you can raise your hand. I'll not ask anything, but just you know that there exists a concept of zero force member. Maybe you can write in a comment yes or no. I'll not ask anything about it, but just to know whether you know that or not. Okay, ठीक है. So some of you know about zero force member. So we'll see in today's lecture that how can we reduce this huge trust problem into a simpler problem so that we can solve it in lesser time. Okay, so there is a concept called zero force member. What is zero force member? So there are some members in a truss in which don't carry any force for a particular loading. For example, this truss for this particular loading, that is loading P at joint E, there are some members which do not carry any force. Then you might ask that why they if they don't carry any force, so why do they exist? Okay, if they are not contributing in any way, then why do these such members are casted? So the simple answer is, for this particular loading, let's say the member, let's say it's M. So let's say the member DM is a zero force member. DM does not carry any force, but for this particular loading, maybe at when the load is at D, then this DM will carry some force. So a member can be a zero force member for a particular loading and can carry some force for another loading. Okay, so in this problem we are given the loading, that the load acts at E, and for that particular loading we need to calculate the value of magnitude of force in member EF. Okay, see, so for using the zero force member concept, I'll tell you some steps. If you'll follow that steps, then you will be able to identify the zero force member. If once we have identified the zero force member, then we can remove those zero force member from our analysis, and in that way we will able to simplify the truss. Okay, let's see what are those steps. So the step 1 is, for a given joint, we have to set up a coordinate system. For example, let's say it's a joint. So we need to set up, the first step is we need to set up a coordinate system at the joint having maximum 3 connected members. Okay, so we need to choose a joint which has maximum 3 connected members. We will set up a coordinate system for it. Let's see how. So for this particular joint, I have put a coordinate system. let's say it's y and it's x. Okay, so the first step is done. We need to set up a coordinate system for a joint. What is the next step? The next step is we will write, we will let's say name the forces. Let's say it's P, let's Q, and it's R. Okay, the first step is set up a coordinate system. The second step is name the forces. Then the third step is we write number of forces in x direction, number of forces in y direction, and we can let's say joint. So let's say it's joint A. So we are analyzing joint A. What are the number of forces in x direction? In x direction, if we'll see, there are two forces. One is P and another is R. So the number of forces in x direction we'll write as 2. What are the number of forces in y direction? There is only one force, which is the component of q. Let's say it's theta. So the number of force in y direction is q sine theta, right? There's only one force. Other than q sine theta, is there any force in y direction for this joint? You can write yes or no in the comment. For this particular joint, is there any force other than q sine theta for this joint? No, right? So it's okay. So for number of force in y direction is 1. Okay, then we can conclude that that particular force, I'll tell you why, then we can conclude that q is 0, and hence this is a zero force member. How we can say q is 0? Because whenever we analyze a joint, we satisfy two types of equilibrium. One is horizontal equilibrium and one is vertical equilibrium. To satisfy for this joint A, to satisfy the horizontal equilibrium, we have two forces. For this joint, P and R must be balancing each other, but there is no other vertical force to balance the load q sine theta. It means q sine theta has to be 0 in order to satisfy the vertical equilibrium, because if q would have any value, let's say q would be 2 kilonewton, then there should be some other force here to balance this value of q sine theta, but there is no force. This means that q is 0, right? So we don't have to think that much. We'll simply say number of we will the first step is we'll set up a coordinate system. We will name the forces, then we'll write number of force in x direction, number of force in y direction. If then there's some if the number of force in any direction is 1, then that force is 0, simply that, and that member is a zero force member, right? We'll see another one. Let's see, there's another joint. So we can rotate the coordinate system according to our convenience. For example, we'll set up a coordinate system like this in this case. Let's say it's y axis and this is x axis. The second step is mark the forces in all three members. What is the next step? Number of force in x direction and number of force in y direction. Number of force in x direction are, so let's say first we'll study y direction. Number of forces in y direction are 2, that is P and R, right? The y direction is 2. Number of force in x direction is only, let's say it's theta, so it's only q sine theta. So number of force in x direction is only 1. This implies that that particular force q is 0, and this is a zero force member. Okay, let's see one more case. Let's say if in this particular joint only I have this force, external load P. So what we'll do, we'll set up a coordinate system like before, right? Let's say it's y and this is x. We will name it as P, Q, and R. Okay. Now the other thing is we will write number of force in x direction are, let's see, number of force in x direction are, there will be a component of p here. Let's say this is theta. So this will be component of p here will be p sine theta, and component of p here will be p cos theta. Okay, now we'll see number of force in x direction total will be, that is p sine theta plus q sine theta, that is 2. Number of force in y direction will be, p and r are already there, one is p cos theta, one more, and q cos theta, so there are 4 forces. Since there is no direction in which the number of force is 1, therefore we can have no conclusion about zero force member. Okay, so we cannot say if any member is zero force or not for this particular case. Okay, so for zero force member, there should be only one force in any particular direction, then only we can conclude anything about zero force member. Okay, so you have seen all the cases. Is there any doubt till now? If there is no doubt, then we'll start with the problem now. Okay, we'll have so many joints to analyze, so if you have any doubt, it will be cleared. Okay, now we'll start with our problem. So in our problem we will find, yes, okay Harini, I'll in this problem I'm going to analyze each and every joint in the same way, so you'll get to know. If there is any doubt, it will be clarified. Okay, so in this problem, let us use the same concept of zero force member and try to solve this problem. So for zero force member, first step is we need to choose a joint. We need to set, second step is we need to set up a coordinate system. The third step is we need to name the forces, and then we will see in which direction there is only one force. Let's see. So we will write the joint name first. Joint, number of force in x direction, number of force in y direction. So we can choose a joint which has maximum 3 connected members, not more than that. Okay, so which joint should I choose? Let's say I'll choose a joint number D. It has 3 connected members. Okay, so we have chosen the joint. I've chosen the joint, that is joint number D. It has 3 connected members. So let's say this. So first thing is set up a coordinate system. I've set up the coordinate system. Then I have named the forces as P, Q, and R. Okay, I've named the forces as P, Q, and R. Then the other step is, what is the number of force in x direction? Number of force in x direction is, let's name it as, this is y and this is x. Number of force in x direction is 2. Number of force in y direction is 1. Only q1 is there, 1. This implies that q is 0, and that particular member is a zero force member. This member is a zero force member. So I'll mark it as this, and then I can remove everything. Now this, I've got one member as zero force member, and now I can also remove this member from our analysis. Let's choose some other joint. Let's say joint number B. I've set up a coordinate system. Let's say it's y, it's x. Then other step is naming the, let's say it's P, it's Q, it's R. So I'm analyzing joint number B. Number of force in x direction is 1. Number of forces in y direction are 2. This implies that Q is 0. This implies that Q is 0, hence this is a zero force member. Right? Now I can remove this all the things. So we have got two zero force members now. Harini, now is it clear? Is it clear, Harini? Okay, ठीक है. I'll some let's say which joint should let's say joint number H. I'm taking random joints, okay? Let's say joint number H. So I make up the coordinates system. I'll name the forces. Let's say it's P, Q, and R. Number of forces in y direction is only, we are analyzing joint number H. Number of force in y direction is only 1. Number of forces in x direction are 2, right? P and R. This implies that Q is 0. Hence, we can write this as 0 force member. So you'll see in this big truss how many members are zero force members. Zero force member means all these members can be removed from the analysis. So in this step, I'll find out all the zero force member that are possible for this structure, and then I'll remove all those zero force member, and then our analysis will be simplified and we can easily find the value of EF, force in EF. Otherwise, in this big truss, what you'll do, you have to first find the reaction, and then you need to go joint by joint, and till then you can reach joint number EF, and then you have to analyze what are the forces in member EF. Okay, so that big question, we are now simplifying it by using the zero force member concept. Okay, so what other thing we can choose which has maximum? Can you suggest which joint should I use? Should I analyze now? Anyone? Can you suggest some joint? Joint number C. Okay, joint number C we can analyze, but after some time, because it has this member. So we have so many. I'll analyze joint number C, but after some time. Any other joint? So let's see, I can also analyze joint number E now. No, we cannot analyze joint number E because joint number E has more than 3 members. So I'm saying the joint which has at least, which has maximum 3 members. So let's say this joint is not named yet. Let's say this is joint number M. So this joint has now 3 members, right? Because these 2 members have now become zero force member. So now I can analyze this joint M. I'll see why I have not taken before. I'll tell you later. Okay. So let's analyze joint number M. How many members are connected in M? 3, right? Because this member DM and BM has now become zero force member. So please neglect those members now. So I'm analyzing joint number M. So what was our first step? The first step is set up for those who have joined late. The first step is to set up a coordinate system. So I'm setting up this coordinate system in joint number M. Okay, let's say it is X and this is Y. Second step is naming the forces. Let's say it is P, this is Q, this is R. So we'll write here what is the joint I'm analyzing. I'm analyzing joint number M. Number of forces in X direction are 2, that is P and R. Number of force in Y direction is 1, that is only Q. Other than Q, there is no other force which is acting in Y direction. It is 1. This implies that Q is 0. If any particular direction has only one force, then that particular force has to be 0 to satisfy the equilibrium. So in Y direction, there was only one force, so that force should be 0. Hence, we can conclude that Q is 0. Since Q is 0, so this member is a zero force member. After marking the zero force member, I can remove this coordinate system. Now I'll analyze joint number C, which you were saying. Now I'll analyze joint number C. The first step is setting up the coordinate system. Okay, marking the forces. It's P and it's Q. Okay, let's see. So I'm analyzing joint number C. Number of force in X direction, this is X direction, this is Y direction. Number of force in X direction is what? Number of force in X direction, can you write in the comment? Number of force in X direction. Please be interactive, otherwise it will be number of force in x direction is 1, only 1, right? Because other than q there is no force in x direction. This is the x direction. Other than this, at this joint, other than q there is no force in x direction, so we can write number of forces in x direction as 1. And number of force in y direction is also 1, that is p. Other than p there is no other force in y direction for this particular joint c. So this implies that, since if the number of force in any direction is 1, then that force is 0. In this case, number of force both in x and both and y direction both are 1. This implies that both p and q are 0. Because why p and q should be 0? Because in order to satisfy the vertical and horizontal equilibrium, there should be at least two forces. If we will assume that there is some force q, then there should be some other force which has to balance q. Okay, otherwise the horizontal equilibrium is not satisfied in this joint. Therefore, if the number of force in any particular direction is 1, that force has to be 0. In this case, for both x and y direction, there is only one force, hence both these forces are 0. Hence, we can conclude that both P and Q are 0. Hence, this one and this one both are 0 force member. Right? So you see how many members we have reduced till now. For this big truss, how many members we have removed from our analysis till now. Which other joint we can analyze now? Let's analyze joint B again. Let's analyze the joint B again. So first setting up the coordinate system. Now I can move a little faster. This is already, BM is already a zero force member, BC is already a zero force member, which we can name this as P. So we are analyzing the joint number B. Number of force in x direction is already, there are no forces in x direction. Number of force in y direction is only 1. This implies that P is 0. Hence, this is also a zero force member BA. We can remove everything here. Now, which else member we can analyze? So now this is taking time, but once you are like familiar with the steps, you will do it faster. Even when you look at any joint, you can say which is a zero force which has zero force member connected or not. We have set up a coordinate system here. There, or DC and DM are already zero force member. We will name it as, let's say, P, the member DE. So we are analyzing joint number D. Number of force in x direction is 1. Number of force in y direction is 0. This implies that P is 0 and DE is a zero force member. Which else joint I can analyze? Let's say joint number. So I'll try with all the joints, okay? So that at least which has less than or maximum 3 members. So I'll analyze all these joints. Let's analyze joint number J now. Joint number I, someone is suggesting. Which is it, I? Sorry, it's I. This is I. So I'm analyzing joint number I now. So I'll name this as P and this as Q. I'm analyzing joint number I now. Number of force in, this is X and this is Y, right? Number of force in X direction is 1. Number of force in Y direction is 1. This implies, since number of force in both X and Y direction are 1, we can conclude that both P and Q are 0. And both these two members are zero force members. Right? I hope till now you are familiar with the concept. Any other member which I can analyze? Any other joint? Okay. So I think these are the only joints which has zero force members connected. So all the zero force members are identified till now. Let's see for this. Let's see joint number F. We can check now joint number F also. Let's check joint number F. Let's check joint number F. So we are analyzing joint number F. We have set up the coordinate system. We'll name it as P, this as Q, and this as R. Right? So now number of force in x direction are, this is x direction. So there are two forces. One is P, this is x, and this is y. Number of force in x direction are, one is P and another is, suppose this is theta, another force is Q cos theta, right? Two forces, one is P and another is Q cos theta. So number of forces in x direction are 2. Number of force in y direction are, one is R and another is Q sine theta. So number of force in y direction are 2. Therefore, no conclusion about zero force member. Okay, we can only conclude about zero force member if there is only one force in that particular direction. Is it clear? So that's why we cannot conclude anything about zero force member. So we cannot mark any zero force member here. So we have similarly you can check with other joints as well. So we have identified all the zero force members now. So what we can do, this step took time for the first time this time, but when you will be familiar with this concept, then it won't take much time for you. So you'll simply see the truss, you'll remove the zero force member, and then you'll start analyzing the truss. So we have identified all the zero force member now. Now we can remove all those zero force member and we'll start our analysis now. So in this step, I have removed all the zero forces, so zero force members. Now that big truss has become a very simple now. As you can see, this was the problem which was given to us. This big problem we have identified with the help of the zero force member. We have reduced our problem to this much small problem. Now it is easy for us to analyze this stress. Okay, so we'll now use the method of section to analyze it. We can also use the method of joints, but it is simpler in this case to use a method of section. So what we will do, first we will identify the reaction. So this is joint number A and this is J. Let's name it as vertical A, that is vertical reaction in A, and horizontal reaction in A. Let's name it as vertical reaction in J and horizontal reaction in J. Now we have cut this section because we need to find the force in EF, so we have cut this section like this. Okay, so what we can do, we can name this force as FEF and this force as FEG. Also, we can write our reaction as VA and HA. So we have cut this section and we have drawn all the forces that are possible here. Now we will solve. Okay, I'll mark it here also, FEF and FEG and VA and HA. This is joint number A. So now let us take, now we have what we need to find FEF, that is force in the member EF, magnitude of force in member EF. So we will use the equilibrium conditions now. Now we'll take summation of moment about point number E as 0. So what we will what will be the values? Let's see them, mark the distances also. So this distance is given as 4 meter. Okay, and this distance is also given as 4 meter. You can check in the question also, distance between E and A. Right, so this was our question. Distance between E and A, this distance is A or A, that is 4 meter, right? And the vertical distance is also 4 meter because the value of A is given as 2. So those distances I have marked here. Now summation of moment about point E is 0. Please see the steps very carefully. I'm just taking the moment about point E. So let's see what is the force when we'll take. So HA and VA are the two forces, right? So HA multiplied by distance from E to HA is 4 meter minus, because if we will look at point E, this force HA is rotating in anti-clockwise direction, and this VA is rotating in clockwise direction, right? Therefore, we have chosen the signs accordingly. So HA into this distance 4 meter and minus VA into distance is 4 meter for this case also equal to 0. There is no other force than HA and VA, right? Now, from this we can conclude that HA is equal to VA. The first relationship we got as HA equal to VA. Now, what other relationship we can find out? Other relations are, because we need to find FEF, right? So we will take the summation of force in y direction as 0, because we need to somehow find a relation between FEF with other forces. So I have chosen summation of moment about summation of force in y direction as 0. So what are all the forces in y direction? FEF plus P is also in y direction, right? And the force in y direction is VA, which is in opposite direction to FEF. So let's call it as minus VA equal to 0. Okay. So we have got a relation like FEF is equals to VA minus P. So I've got another relation, FEF is equals to VA minus P. We already, in the question, the value of P is already given. So once we find out the value of this reaction, vertical reaction VA, we can simply find the value of FEF. So let's see how can we find the value of VA now. Now we'll take the entire truss. This is A. Let's call it as VA. It is HA. Now, what we will do, we will take the summation of moment. Now, I've told in this step that if we get the value of VA somehow, we will be able to find the value of FEF, right? So, our target is to find the value of VA now. We'll take how we can find the value of VA. We'll take a moment about point number J. Point J, summation of moment about point J as 0. So let's see what are all the forces. There's a force called P, and the distance between P and J is, what is the distance between this point E and J? Let's see. The distance between point E and J, perpendicular distance, this distance is 4 meter, right? A plus A. So it is 4 meter. What is the other force? There is HA, okay, plus HA. What is the distance, vertical distance between J and A point? This perpendicular distance between J and A point is, this entire distance is 4 meter. This is entire distance is 4 meter, and this distance is 3 meter. It is given that. Therefore, the distance between J and A is 1 meter, right? 4 minus 3, 1 meter. So this is 1 meter. So HA into 1 meter minus VA into distance between VA and J is 8 meter. Right? So it is 8 meter equal to 0. Now 4P plus H. From this we have found out that HA equal to VA. So we'll replace HA by VA minus 8VA equal to 0. 4P minus 7VA equal to 0, and VA equal to 4 by 7P, right? 4 by 7P. Now it is easy. We know the value of VA. We can find the force value of FEF as VA minus P. VA is 4P minus 7 minus P. So FEF, we got it as 3P by 7. What is the value of P which is given to us? The value of P which is given to us is 70 kilonewton. So we'll put the value of P here now. We'll put the value of P. So FEF we get as minus, so it's minus 30 kilonewton. So this is our final answer. So what was asked? It was asked that the magnitude, that is absolute value. Absolute value means the magnitude of which, means negative, positive, it doesn't matter, only the value. So it was asked that the magnitude of force in the member EF is, we can write it as 30 kilonewton, right? So this is our final answer in this case. See, it was a very big question. If we would have solved it using the entire method of joint or method of sections, but what we did, we reduced the truss. Although even after reducing the zero force member, it was indeed a lengthy question, but the idea is, if we know the concept of this zero force member, what we can do is, in any gate question, they might ask that, name the number, what are the number of zero force member for this truss. So instead of asking the force at particular member, they might ask what are the number of zero force member for this particular truss. So they can ask you this question directly also, and they might give you a very lengthy truss to solve. So if you would know the concept of zero force member, then only you would be able to solve that in that particular limited time. Okay, so this concept of zero force member is very important while analyzing a truss. Okay, so here's a practice question now. So this is a practice question. This is from NPTEL weekly assignments only. So I want you to try. The question was to identify the number of zero force members. So maybe you are like 5 6 people. So maybe you can tell me, maybe one of you can solve, or all of you should try to solve the number of zero force member. At least 2 3 members you should identify each. So let's try. Okay, let's try for some time, and then I'll tell you. Maybe try to identify some zero force member, and please write in the comments what are the members you got. Okay, otherwise I'll do it for you. At least one member you all can identify each. You can write in the comment if you, GB is a zero force member. That is right, correct, very nice. Any other? So this type of question you can also get in gate, that identify the zero force member. Okay, HE. It is HE, yes, very good. HE is also a zero force member. MJ is also a zero force member. So after a lot of practice, you'll see the truss, and you can remove the zero force member. Then you just have, like, it will be a 2 mark question, right? It is a 2 mark question. So a 2 mark question you can just solve in within a minute. Okay. Is KN is a zero force member? KN. Very good, very good. Nice. It means, or maybe I can ask, is OR is a zero force member? OR, is OR is a zero force member? Mm-hmm. Please check again. Please analyze the joint R. Yes, right. OR is also a zero force member. Maybe if I would have asked RO, then you might give me a correct answer, but it's okay. Hmm. So in this entire truss, there are 10 zero force member. Okay, there are 10 zero force member. So maybe it might be kind of a puzzle to so some of them. uh, so how many zero force member you could identify till now, each of one of you maybe? Okay, maybe I'll ask, uh, is IJ a zero force member? MJ, you know, na? MJ is a zero force member, you have already told me. Is IJ is also a zero force member? Yes, very nice, very nice. So you're getting the concept, right? So just don't leave it here right now. Just download or maybe find every problem related to zero force member and try to solve it, so that that concept seeps in your mind. Okay, so I hope this concept of zero force member is like understood. Okay, so now I'll move to other another problem. This you may try in your home, maybe there. So I have told you the answer. There are a total 10 zero force member in this truss. Hmm. So let's see if you could identify those or not. So now I'll move to another question that is very simple problem. So after that I'll close. So this is also a gate question. So you'll see some questions are of 2 marks, and they are very easy to solve. Okay, and some 2 marks question are very very lengthy. So but after a lot of practice, you would be able to identify the questions which will take lesser time for you. So you should attempt those questions first, because anyhow you'll be getting 2 marks only, right? So at least you should cover more, as many problems as you can. Okay, so you after some practice you'll know that trust problem anyhow will take a time. To analyze a trust, it will take a time, so you may want to solve it later. Okay, and first you can solve some easier problem. So let's say this was an easy problem. So in this question, it was is a gate 2022 question of set 1, question number 37. So in this question, there is a semicircular bar of radius r in vertical plane. It is fixed at the end G. As shown in the figure, a horizontal load of magnitude P kilonewton is applied at the end H. So here P kilonewton is applied. The magnitude of axial force, shear force, and bending moment is asked at point Q, which is having a theta of 45 degree. So it is given that this theta is 45 degree. So we have so they asked us the value of axial force, shear force, and bending moment at point Q. Hmm. Okay, so I hope you know that for a bar, let's draw a bar here. So if it's a straight bar, so the force which is perpendicular to the to its surface, this force is the axial force. I hope you know that, right? This is axial force because it is along the axis of the bar. Okay, this is axial force, and this is which is along the surface, which is perpendicular to the surface, is the axial force, which is along the surface is the shear force. Hmm? So they have asked us the value of axial force, the shear force, and bending moment at point Q. And where is point Q? Point Q is at, when we draw this at 45 degrees, so here is the point Q. So we need to find the value of all the three things. So let's start with the problem now. Hmm? Now, first we will identify the value of bending moment. It's a very simple question. Okay, you'll see. So they have asked the value of bending moment at point Q. So this is the point Q, and they have asked us the bending moment. We all know that what is the how the bending moment is calculated. The value of bending moment will be force force multiplied by distance, right? This is this is how we calculate the bending moment at any point. So here the force, we have to find the bending moment at Q. Okay, so we'll start with this end. Huh? What is the value of force? The value of force is P. Other than P, there is no other force, right? In this whole structure, other than P, there is no other force acting. The value of force is P. And what is the distance between P and Q? Perpendicular distance between P and Q. This distance M, right? This is the distance between perpendicular distance between point P and Q, and that is, I have named it as M, let's say. So we will calculate the bending moment. How? Force is P multiplied by distance M. And now what is the value of M here? We can easily find the value of M using trigonometry. Like, what is the value of sine 45 degree? Like, this is the value of M, right? So we can find sine 45 degree. Sine 45 degree will be perpendicular divided by hypotenuse, right? So value of hypotenuse is given, that is the radius of that bar. So it is M by R. What is the value of M now? M will be, P will be R sine 45 degree, right? The value of M we have calculated as R sine 45 degree. So what will be the value of bending moment? It will be P into M, that is P into R sine 45 degree. So we have got our answer, PR sine 45 degree. What is the value of sine 45 degree? 1 by root 2. So we have got our answer as PR by root 2. So one of the value is we have found out, that is PR by root 2 kilonewton meter. We have asked shear force, axial force and bending moment. Bending moment we have easily found out. What is it? Bending moment is force into the perpendicular distance. So force was P and perpendicular distance between P and Q was, we have named it as M. So what is the value of M? We have calculated using trigonometry. So the value of M is comes out to be R sine 45 degree. So finally we have got a value of bending moment as PR sine 45 degree, that is PR by root 2 kilonewton meter. So out of all the three values which they have asked, we have found out the value of bending moment. Now axial force and shear force. To find the axial force and shear force, I have cut this section. So wherever you need to find the shear force and axial force, we can cut the section from there. So I've cut the section at Q and draw it here separately. So I've cut the section at Q and draw this part separately here. Okay. So now, please see carefully. This force is given to us as P, right? Since this force is P, and this is the section. This is my section, the half section which I have cut it before. So this is the value of P. So if this is P, let's say it's not there, P cos theta, P sin theta, just forget it, okay? Maybe I'll draw it separately. So I have cut this section as this. Now this is given to us as P. If this is P, then in order to satisfy the horizontal equilibrium, what would be this force here? This force will also be P and in opposite direction. I hope you agree, right? If this force is given as P, so this force should also be P in horizontal direction. That is what I have drawn here. So I have drawn this force P, so this force should also be P. Now what they have asked us, shear force and axial force. So we have already discussed that axial force is perpendicular to the surface and shear force is along the surface, right? So now we know the value of P which is acting here, but they are not asking the value of resultant. They are asking the value of shear force and axial force. So we will take the component of P in horizontal and vertical direction, and that will be a value of shear force and bending moment. That is a simple thing. This is P, right? So we can take a component. This angle will, since this is 45 degrees, so this will also be also be 45 degree. So we will take the component of P in horizontal and vertical direction. When we will take the component in x, let's say it is x direction. When we'll take the component in x direction, it will be P sine 45 degree. When we'll take the component in y direction, it will be P cos 45 degree. So I'll draw a bigger section maybe. So this is the cross section. This is the cross section of the bar. This is the cross section of the bar. So we are asked the value of shear force and bending moment. So what will be the shear force? Shear force is the force which is along the surface. So what force is along the surface now? This force, right? This is along the surface, and the value is P cos theta, which is perpendicular to the surface. This force is perpendicular to the surface, and the value is P sin theta here. Hmm? So what we were asked these values only. So we were asked what is the value of axial force. You can tell which this one is the axial force, right? So it is P sin theta. We are asked the value of shear force. So shear force is the force which is along the surface. So this is the force which is along the surface. Hmm? So the value of shear force is P cos theta. So axial force is P by root 2 and shear force is P by root 2. So our option will be option number A. What is that is P by root 2, P by root 2 and PR by root 2 kilonewton meter. Okay, so it was a simple question. Just you should know the concept that what is an axial force and what is a shear force. Other than that, it is a very simple question. Hmm? Any problem with this question? If not, you may ask. You may write no or say no.
Hello, ma'am.
Huh?
Ma'am, how it become axial and shear? Please repeat the
Okay,
question.
ठीक है. Okay. So in this problem, we are asked. Maybe you can mute or yourself, Manavendra. Yeah, thank you. So uh, I hope you have muted yourself. Thank you. So in this problem, we are asked the value of axial force, shear force, and bending moment. I think bending moment is understood. Now the other thing is axial force and shear force. So what I did is the section at which we have to calculate the axial force and shear force. We will we will cut our bar from that particular section. Hmm? So I've cut that bar from that particular section, and I've made a separate bar here. So here I've made this particular section which I have cut down. So in this problem, this is given loading P. So at this is point number Q, okay, and this is point number H. So it's point number H and it is point number Q. So since this is P, right? So in order to maintain the horizontal equilibrium, this force should also be P. Hmm? But in this question, they have asked the value of shear force and axial force. So what is shear force and axial force? So shear force is a force which is along the surface. Okay, so for simplicity, I can draw the like this bar is shown with a line section, right? So I'm drawing the full section of the bar. So this is the full section of the bar. Hmm? So this force we know now, since this is P, so this is also P, right? This is clear, I hope. Now we are asked the value of shear force and axial force. So axial force will be this force, right? The force which is perpendicular to the surface, and shear force is the force which is along the surface, right? So we can find out the component of P in x and y direction, and that will be a value of shear force and axial force. Okay, because they have not asked us a resultant force at point Q. If they would have asked the resultant force at Q, then P would be our answer, but they have asked the shear force and axial force. So by definition, we know that the axial force is perpendicular to that section or surface, and shear force is along the surface. So we have found out the components of P in both these direction, and that will be a value of shear force and axial force. I hope it is clear now, Manabendra.
Yes, ma'am.
Okay, ठीक है. So for now we are done. I want to give you a homework problem, let's say. Please try it at home, because like last time I've explained this kind of problem. Okay, let's say it is 2 kilonewton per meter, and this is 5 meter, let's say. This is A and this is B. So using that standard deflection formulas, I want you to find the value of reaction at B. So please try this at home. But although you can use the other methods also, but since that concept is very important, standard deflection formulas are very important for gate. So please try to find out the value of RB, that is a vertical reaction at B. Okay, say it's a roller support. it's a roller support. So vertical reaction at B using deflection formulas. Okay then, thank you for today.
Thank, thank you,
Any
ma'am.
any questions or any suggestions maybe? So I'll upload this video and you'll get the recording link. I most probably by this week. Okay, so you can check the recordings later on also. Okay, then thank you so much for listening. Bye everyone.